Hey everyone, thank you for joining us for today's Lunch and Learn. If you're not on our meetup, we have a Lunch and Learn every 2 weeks from 12:30 to 1:30 p.m. Search DevOps on meetup.com/groups, and we're the largest DevOps and cloud group in the DFW area. Today's topic is about data security in DevOps automation. We have two excellent speakers here today. Thank you for joining us for today's Lunch and Learn. If you're not on our meetup, we have a Lunch and Learn every 2 weeks from 12:30 to 1:30 p.m. Search DevOps on meetup.com/groups, and we're the largest. Sorry, I think we have an echo here in the DFW area. Today's topic. So today we have two excellent speakers with us today. We have Diallo Gentry, who has over 20 years of experience in the information technology space, and he's been working on projects of varying complexity and has had projects in governance, architecture, third-party risk, vulnerability management, and application security. Our other speaker today is Nicolas Vautier. He's a software engineer with over 12 years of experience building enterprise and secure workplace collaboration tools. He has contributed and is listed as an inventor of patents for many policy enforcement and digital rights technologies. Today, Nicolas is a developer advocate at Ionic Security. I'd like to thank these two speakers for joining us for today's event. And without any further ado, let's hear from them. Diallo, if you want to unmute yourself.
Can you hear me now, Sri?
Yep, we hear you.
Loud and clear. All right, great. Thank you. Thanks for that intro, and good afternoon, good morning, and good evening. Just to make sure I've covered all my bases, depending upon where we're dialing in from. On behalf of Blake, Nicolas, and myself, we're glad that you could take some time to join us out of your busy day. And thank you to Invati for hosting the event. I'm Diallo Gentry, and for the next few minutes, I'm going to offer some observations, perspectives on data security as it relates to DevOps. As they say, we're just going to hit the peaks because there's a lot of depth and detail for this subject. But hopefully today you'll gain some benefit from the conversation, including awareness and or a bit of what to do and even how to do. Before I dive in, let me just say a brief word about Ionic Security and Ionic Machina. Machina is a policy-based authorization engine that provides an increasingly cloud-first world with the ability to protect, control, and maintain visibility of your digital assets at machine scale through a programmatic interface. In short, it means that we help you implement your data protection requirements as code so you can implement those controls uniformly across your digital ecosystem. If you have questions or would like more information, any of the three of us, myself, Nick, or Blake, would be glad to help. But now on to today's topic. So just a quick start with the agenda so you can see the direction that we'll be going here. We're going to touch on some of the expectations around DevOps. And from there, we'll transition to what are some of the bad things that can happen or that we should be on guard for, along with some recommendations for avoiding and or correcting those things. My colleague, Nicolas Vautier, is going to provide us with a demo today to show one method for protecting confidential information in the DevOps pipeline. And we'll also share some resources with you so you can replicate what you see here today. Obviously, at the end, we'll leave time for some questions. So I'm sure everyone has seen some version of this diagram, the DevOps flow. DevOps, this set of practices that reside with the IT organization that, when executed well, brings several benefits to our businesses, including faster time to market for our products, better customer experience, increased product quality, and the one that we hear frequently, the fail fast, fail safe. And much of the DevOps emphasis has focused on shortening the time between code to shipped product. But what's been interesting over the last several years is watching the definition of code expand from the traditional sense of source code as we often think. So as we look around in our IT departments today, code is everywhere and part of everything's. In many ways, this has always been the case. This has always been true. But with the prevalence of cloud and software-defined everything at this point, code is really taking center stage. So today, code is what it always has been and more. It's our source code that creates the products that many of our organizations offer, but it's also the configuration files and automation scripts that are responsible for defining and building the infrastructure on which a lot of that code runs today. So we're using code across a broad range of tools now, everything from Chef to Puppet to Terraform, Ansible, many, many others. I've represented just a few of those here, but please forgive me if you don't see your favorite tool because, again, there are a lot of these. But with this expansion of code and our use of code today, one of the things that we're observing is that the risks that have historically been associated with code are finding their ways into more and more places across the enterprise. And these risks are not new. Our developers in many instances have been dealing with these kinds of challenges ever since we've been using software in business. But what's happening today, because again, the expansion of the meaning and definition of code, more and more IT professionals are having to deal with and manage these risks. So again, this can be a fairly deep pool to dive into, but let's look at some of the common risks that affect infrastructure as code in particular today. So we have undefined standards, absence of poor monitoring across the pipeline, the potential for widespread propagation of misconfigurations, the excessive use of privilege within infrastructure as code tools, potential vulnerabilities in infrastructure as code templates, and the one that we tend to spend a lot of time on, certainly I've spent a lot of time on in my career, is the exposure of sensitive information. And today that not only comes about through some of the common sources that we would typically think of, for example, a database or even unstructured data within an organization. But again, we're finding more and more sensitive information, such as credentials, secrets, configuration elements, within these new tools that we're using in our cloud environments. And because all of these things are being treated as code, one of the tools, resources that we're finding in greater use today are code repositories. And code repositories can certainly have a dark side. And I'm going to spend some time here just talking about a couple of identified and publicized examples that some of you may be familiar with. Uber and Linda both experienced breaches in the fall of 2016. And when we go back and look at how those breaches occurred, what we will find at the center of that breach is GitHub and the fact that attackers gained unauthorized access into GitHub. Once there, they were able to search through, GitHub repositories, and in this case, they identified repositories for Uber and Lynda that contained AWS credentials. As a result of that, those attackers were then able to pivot and directly attack both Uber's and Lynda's AWS environments, resulting in the compromise of thousands, in the case of Uber, millions of user account records containing personal information of users for those organizations. Now, that's an impact to consumers, which is something all of us need to be terribly concerned about, because it's our consumers' data, our customers' data that we need to be protecting. But also, depending upon how organizations handle some of these events, there can be significant consequences for the organizations that suffer these attacks, as in the case of Uber. Unfortunately, part of their damage was self-inflicted because they did a poor job of reporting the breach at the time. From a monetary standpoint, that breach cost them $148 million and also requires them to submit to 20 years of privacy audits from the FTC, the Federal Trade Commission. Another more recent example, and I found this online just a few weeks ago, still revolving around GitHub, security researchers were actually able to identify GitHub repositories from which credentials and other sensitive information, in this case, medical health records, were leaking. And that could be due to either misconfigurations in those data stores themselves, or again, if credentials are exposed, then it opens the door for attackers to pivot and gain access to, unauthorized access to, those storage repositories. Just to point out the quote here, number of threat actors misusing or attacking GitHub repositories is anyone's guess. This is happening on a regular basis. And unfortunately, that means GitHub is being recognized as a valuable source of open source intelligence about what organizations are doing, where they're doing it, and then potentially offering an opportunity to penetrate more deeply into those organizations. And quite frankly, while a lot of the emphasis of these examples falls on a service such as GitHub, it doesn't make any difference whether or not the repository is public or private. That is to say, you could have a source code repository, a Git-like source code repository within your organization. If an organization is penetrated, again, attackers know that there are certain areas within the organization that they want to probe, they want to investigate, and they want to look for additional information about where they can go next to further their attack. And so even in the case of a private repository in a private cloud or in an on-premises data center, attackers are going to be looking for source code repositories as a resource to advance their attack. Even just this morning, as an example, I wanted to bring to your attention, you can do this yourself by going out on GitHub and just doing a search. In this case, I was simply searching for password in AWS. And here what you see is just a screenshot I've captured, blurring out the sensitive information, but someone is using an infrastructure tool, a DevOps tool, Ansible, very commonly used across many of our organizations. Looks like this is going to be part of the configuration stored in a YAML file for a MySQL database. And here we can see the customer probably making use of the Amazon AWS RDS service, one of their database services. We see a username, we see a password that was actually stored in this file and findable out on GitHub in this case. So this is something that we certainly need to take appropriate action to be cautious of, most certainly, to avoid, definitely, and to control to the best of our ability. So how would we go about doing that? Many of the possible approaches for addressing these kinds of risks are the same approaches that have always existed. And one of the ones that I always like to start with, for two reasons: it's a good practice and it does require collaboration between multiple teams, and that's threat modeling. And as we talk about the need to shift our security practices in the DevOps cycle to the left, the earlier and frankly more frequent that we do this, the better off our organizations are to know what we need to be protecting against. A second thing that we need to do and continue to emphasize in order to make sure that we're protecting and safeguarding sensitive information is maintaining awareness and visibility. It's always been said in the security organizations that I've worked with or worked for that you can't protect what you don't know. And so therefore, we need to make sure across all of our automated DevOps processes that we have a good awareness and understanding of what exists, what should exist, so we can then find things that don't fit into our world, our environments. From there, defining and enforcing standards as we make use of more of these tools that rely on infrastructure as code, code templates to deploy and build configurations in our environments, in the same way that we have always used scanning technologies to help us as a tool to improve our source code and to avoid the promotion of vulnerabilities out into production environments. We can also make use of the similar kinds of scanning technologies for our infrastructure as code components. Again, making sure that we don't deploy vulnerabilities into the environments from those templates. And then finally, thing that has always been true is protecting secrets and confidential information. Had a conversation with many a developer throughout my career where we ask them not to hard code information into code, hard code secrets into code. But sometimes with some of the tools that we're using today, this is I'll call it a necessary evil. There are ways to manage this, however, and we need to leverage and utilize those ways of managing these secrets in order to maintain the security of our environments. And that can either be removing those secrets or, in some cases, using tools like encryption to protect those secrets. I'm happy to say in that survey this morning, I was finding organizations out there in GitHub that are leveraging, utilizing secret managers for storing and protecting those secrets. My colleague Nick is going to actually share with us an approach for leveraging, utilizing encryption for protecting those secrets as part of the Git pre-commit check. So Nick, I'm going to stop my share here and hand things over to you.
Okay, thank you, Diallo.
Nick, I think you're ready to go there now.
Yeah, do you guys see my screen here?
Yep, sending it live.
Okay, so we'll be demonstrating how to use the machine platform to protect your CI/CD pipeline. Each of these terminal windows represents a repository on the pipeline. The starting point is this source repo is going to simulate origin repository that could be hosted on a hosted service like GitHub, for example. We'll see it has a single commit, and then this top terminal will be the developer endpoint, and the one below it will be the Jenkins build server, which again could be hosted on a service like Circle CI. So as a developer, we will clone the source repository, CD into it, and then we're going to be we're providing a check-in script that we'll do a deep dive into later. But we basically copy it into the repository, into the hooks subfolder of the repo, and set it as a pre-commit hook, meaning it'll execute each time a commit is added to the source code. So we also have to change the permissions so that Git can actually execute this bash script. And now on the build server side, we will once again clone the repo. CD into the repo. And here we'll set the post merge hook with another bash script that we'll provide, which is the checkout script. This one also needs execution. So in this demo, the developer is going to check in a Google services.json file, which is basically a configuration file for Google's Firebase hosted service. So this copy basically copies it into the repo, into the working tree, I should say. If we do a status, we see it's added one file. We can, this is what the file looks like. It basically has several API keys that it needs to talk to the Firebase service. We'll add it and commit. So you'll see when the developer commits that file, it invokes the check-in script, which basically looks for exposed API keys and uses the Machina CLI to obfuscate them. So now the developer will push this to the origin repo, and now the CI/CD pipeline would presumably be polling for changes and check out the code. Here on the right, we have the Machina dashboard, which basically gives you live analytics. We can see each of the protect operations that were invoked by the check-in script. So on checkout, so down on the terminal below, we're simulating the Jenkins service that would poll and do a poll to build the code. So we'll see that it gets the new commit, and then the checkout script deobfuscates these API keys. On the dashboard, see shortly, but this is basically what the file will look like when it's checked out. So in the origin source repo hosted on GitHub, the keys are obfuscated. And then by the time it's checked out by the build server, it has the plain text key. So we can once again check the analytics, and then these are each of the key fetches to decrypt the API keys. What's interesting about Ionic and the Machina platform is, this is utilizing the CLI, but if your application that is actually being built by the build server, for example, actually uses the Machina SDKs, it could, in fact, skip this entire step where you can actually compile the obfuscated API keys into the application and deploy it with the obfuscated keys. And at runtime, the application can decrypt the keys as needed. So that would prevent even the hosted service that's building your application, even being able to potentially have access to your plain text API keys. So let me show. Now I'll just quickly show you the actual bash script that we put together. It's a fairly simple bash script, less than 40 lines. The actual invocation, it actually invocates the machine command line a single time. It's basically just parsing the file, the Google services file with the sed tool, and if it detects that it's a plain text API key, it will just invoke the Machina CLI tool to obfuscate it, and then once again use sed to replace the original with the obfuscated string. And the checkout script basically does the reverse of this operation. With that being the end of our demo, we open it up for questions.
If anyone has questions, you can go ahead and put it in the live event Q&A on your right. Let's see. We do have a few questions here. The first one is, so if there's a smaller company or a company with not as many resources to have a complete procedure in place, what steps are high impact that we can take that we could use to prevent these sort of breaches?
Yeah, no, that's a great question. I think the first step that we always have to start with is the definition of standards, right? When we're looking at the production of code, whether it's source code or whether it's infrastructure as code, the potential to impact, or let me phrase it this way. In order to achieve the desired outcomes, that is to say, avoiding a breach, there are a number of teams that should collaborate together: security, infrastructure and operations, and developers. All three have to be sitting around the table agreeing what it is that we need to do and achieve, and taking steps. How would we go about doing it? So for me, again, and I think generally speaking for most organizations, if you can start with threat modeling, making sure that you have a firm understanding of what is possible to happen, and then once you identify what is possible to happen, you can take steps to define checks and procedures that will help you to avoid those mistakes and those errors.
All right, sounds good. We have another question here. It says, how would you recommend that companies prepare for security audits?
I've been through enough over the years myself. This is where logging and monitoring come in extremely handy. And the reason I say logging and monitoring is because of the fact that you want tools that are going to help you demonstrate that you are doing what the auditors are looking for, right? That's always the crux of an audit. You need to define what you're going to do, and then when the auditors come, you need to prove and demonstrate to them that that's actually what happened. And so tools that help you create that audit trail, that audit log, are extremely beneficial. Anything that you would leverage and utilize, as with the example that Nicolas was showing, when you're doing your code commits, if there are checks that are happening during the process of the commit, those activities should be logged, either in the code repository or through some other event monitoring mechanism. You then want to make sure that you have those reports, those records, available for auditors to review upon request. So again, you want to make sure that you're defining what it is you're going to do, and then collecting the evidence to ensure that those things and to prove that those things were done. Leverage and utilize your automated systems as much as you possibly can in order to make that a less painful process.
Okay, we have another question here. What would you recommend for smaller companies? Would you recommend that they hire outside consultants to handle all their security, or do you think it's valuable to do that in-house?
I think whenever possible, it's good to develop the skill set and the capability in-house. Now, the challenge there is, how quickly do you need to have that capability ready for prime time? So there's a balance to be struck. I can speak from cases I've worked with in the past where we started off with some sort of either managed service or some sort of advisory service that would come in and assist us. But from my standpoint, when I've actually served in those roles as the outside help coming in, typically most of my customers have always wanted to define a path to help them develop their own competency, right? So help the customer develop competency, but sometimes that outside assistance can be very beneficial from the start in helping the organization to get up to speed. But again, especially if we're going to focus on the smaller organizations, everything that you can do to develop that kind of capability yourself, focus on the core, right? Focus on those things that you can do well, can do easily, right? Without sacrificing other responsibilities. And then where you need augmentation, look for that from an outside provider.
That's great advice. What tools and software do you recommend as far as securing GitHub? And are there alternatives to GitHub that have security built in?
Nick, I'd be interested in some of your thoughts there, because I know you've probably played around with some of these things a bit more than I have, but I will say this. GitHub does implement some protections in terms of identifying stored secrets in the repositories. GitHub, GitLab, not familiar with what some of the cloud service providers like the AWS services or Google Cloud Platform, etc. I know they have repo services, and I'm sure they have built in some of these protections as well. But most of the services now do offer something to the customer because they know this is an area of need, an area of emphasis, and quite frankly, this is one of the easiest things to do. But I'm sure there are other additional tools that would be beneficial to help that problem.
Yeah, my thoughts are basically my thoughts on security is if you're relying on third-party services, it's your fate is in others' hands, right? And so as far as common hosted services, GitHub is definitely one of them. One that handles like the whole pipeline, like the whole build server, Circle CI is one that comes to mind. But that's kind of what we're here demoing, is kind of how you can use third-party tools to add a layer of security that you control on top of these well-known hosted services. In this example, we were using Machina to just kind of see the flow of protected data between, in this case, it was a hosted service like GitHub going into a hosted build server like Circle CI. And then you control the data and you can see it each time it's being accessed. Yeah, so those are my thoughts.
Sounds good. What books or resources do you recommend for people just getting into the DevOps space to understand this best practices regarding security?
There are there are several online reports that I've seen I think are very beneficial. The one that I would start with, and I think the most recent published version is the 2019 version, but the State of DevOps report. If I remember correctly, it's a collaboration between Puppet, Circle CI that Nick just mentioned, and at least one other organization that I can't recall off the top of my head. But the State of DevOps report, the last one the 2019 one that I remember reading a little while ago, really did spend a lot of time talking about the implementation of best practices around security. While I think a lot of organizations are continuing to use the DevOps label, we all know that the other label that has been out there in the wild to call emphasis to including and not forgetting about security is DevSecOps, right? But I go back and forth myself in terms of the use of those two labels. And I think today I tend to prefer the DevOps label by itself. Part of my rationale for that is the fact that, yes, we do want security to be an intrinsic part of both the development and the operational practice. However, what we need to do, I think, is to ensure that each of those functional areas, developers, security team members, and operational team members, maintain hold of and take the lead for their areas of responsibility, right? Security professionals aren't going to really be able to tell a developer how to write the code. A developer can't keep up with everything necessary to keep that code secure. And the operations guys and gals are always dealing with, something unexpected, right? So everybody has their own wheelhouse to manage all the time. It's the collaboration of those three together, sitting around the table, working in partnership, that I think really brings out the benefit of everybody doing the best job they can to achieve these benefits that we're looking for as organizations, as in time to market, reducing errors, reducing faults, and making sure that our customers have the best possible experience with the products that we produce. And that experience, part of that experience is ensuring that it's secure. So, definitely take a look at the 2019 State of DevOps report. I think you'll find some good practices in there for how to move forward and how to bring security throughout the DevOps lifecycle. And then also there are a bunch of rich resources that you can then go to from that report for further exploration. Another organization just off the top of my head that I know has been spending a lot of time on these topics is the Cloud Security Alliance. Their obvious focus is security, but they recognize that it is security in service of, again, bringing products, bringing solutions, bringing capability to market to serve customers. And so they spend a lot of time focusing on how to integrate security throughout that DevOps life cycle, and especially when it's deployed to the cloud, which has become an increasing trend for many organizations. There are still a lot out there that have not made that journey or transition to cloud, but there are, many organizations who are surging ahead in that area. And so the Cloud Security Alliance is another great resource to go to, where I think you will find their information useful, and they will likewise point you in the direction of other beneficial resources as well.
Right. So let's see here. How do you recommend companies check the state of their security, like an internal audit, so to speak, and how often should that occur?
That I would have to say is, much as we talk about continuous integration and continuous delivery of software product, I think when we talk about security, it's another one of these continuous processes. So I think in many answers, questions like this, certainly one of the key behaviors, key technologies that will always come up is monitoring and automation. We know monitoring and automation are of tremendous value, tremendous benefit in DevOps, but certainly in security, it's the same. Our environments are large enough and complex enough that human beings simply cannot keep up with everything that's going on, right? There aren't enough hours in the day, and so we have to leverage our technology tools to help us in that effort. The right tools, as an example, and this is just the first one to occur to me, there are several examples, but a tool like Splunk, very commonly used monitoring tool across organizations, and it has the ability to ingest information from a wide number of sources and to filter up to the top those most urgent, most interesting kinds of events so that a brain walking around on legs can go and take a look and find out what's happening there, and is this something that needs to be investigated further. But it's by bringing automation to the table that I think you establish the capability of continually doing security, continually keeping an eye on your environment, because there is too much of a possibility that if you're only doing it at intervals, what do you miss between the intervals, right? And perhaps the volume of information that you have to sort through in those intervals could be so large that you never really effectively get through it all. So again, I'm going to really offer and suggest that automation is one of the things that we can leverage and utilize within our security practices to make sure that we are always keeping an eye on the ball, and then raising those really interesting events to one of our human analysts for further investigation, and making sure that we know what those interesting events are that we should be looking for.
All right, thank you, Diallo. I think that's it as far as questions. Could you guys talk a little bit about Ionic Security and what you guys do over there and how you guys can help before we wrap up?
Yeah, sure. Nick, you wanna hit that one?
Sure. Yeah, so the Machina platform is basically, so Ionic Security is the company, Machina is the product. It's a combination of tools and basically it's a back-end policy and decision engine with the complementing tools, which include SDKs that you can integrate into your application, and the CLI tool that I demoed today. So it's helps you protect. It's not just leveraging you leverage the decision engine to enforce your company's policies of when data should be accessed. So for example, in the demo that we used today, we didn't show any policies, but you can, on the back end, dynamically set policies to suit your enterprise's needs. So for example, in the build server that we simulated today, you can set a policy to say, don't allow it to fetch the keys needed to decrypt the API key, other than the hours between 9 and 5. Or you can say, don't allow the endpoint to access the key in order to decrypt unless the build server is inside a particular building. So if you were to, have a leak, physical security issue and someone removed your build server out of your company's physical walls, they wouldn't be able to run and compile your code. That's it in a nutshell. I don't know, Diallo, if you want to add to that.
Yeah, I suppose I'll probably just tackle into what we've been discussing here today, that idea of code. And as a matter of fact, the article I've read within the past week talked about a security concept of detection as code. And that's not what Ionic does. It's not what Machina is for, but it's just the notion of even security is finding its way to express itself in terms of code. And that, I think, is what Machina does really, really well. One of my customers is a large financial services organization, and hopefully many of you on the call today might appreciate this. We know that there are always defined policies and standards, for example, how you handle data of varying classification or sensitivity within an organization. And when I used to work in financial services, I mean, we literally had volumes of policies and standards that told us how we were supposed to do that. The challenge was always the fact that we could never provide any technical means of enforcement. Mind you, I'm talking years ago, but things have changed and things have evolved and things have improved because now we have platforms like Ionic Machina where we can ingest that policy, right? Security administrators can create policy within Machina that says, here is how sensitive data, and obviously the organization has to define what they mean by sensitive data. Here's how sensitive data must be handled and who has access to it and where they have access to that information. Where can that access originate from, geographically or on a network or particular device, etc. And several other pieces of metadata that we use to make a decision around that who has access question. And so what my customer, the bank, was able to do is essentially convert their policy volumes into code and then uniformly enforce that across their banking organization. And that banking organization is a large one, so it's comprised of a number of different businesses. But now what they have is the ability to say, if this is credit card data or if this is personal information, they have a very high degree of assurance that those data types are being handled in the same and consistent manner across all of the businesses, which was always a goal that they had worked toward, but it was just extremely hard for them to achieve. And we were able to help them achieve that using the Machina platform. So really what we like to think of ourselves as doing is taking on and removing some of the complexity from especially the developers, right? So they can focus on core business functionality, core capabilities that customers want, deliver that, and then rely upon a platform like ours, essentially a service, an API call for handling all that security authorization when accessing data. So we do take a huge burden off of organizational developers in that respect. And our customers, I do believe, have been very happy with the results that they've achieved.
All right, thank you guys. Huge thank you to Ionic Security for partnering with us today to host this informative seminar. Thank you all for joining us for today's Lunch and Learn. Again, if you're not on our meetup, we have a Lunch and Learn every other Wednesday, and it's from 12:30 to 1:30 p.m. on a Wednesday. Search DevOps on www.meetup.com/groups, and we're the largest DevOps and cloud group in the DFW area. So I will see you all in the next one. Thank you. Have a nice day.
Thank you, everyone. Thank you, Sri.
Oh.